Welcome to The Explainer. You ever wonder how successful businesses seem to have a crystal ball for the future? Well, what if I told you it's not magic, it's just math? Today, we're going to break down how anyone can turn a simple hunch into a seriously powerful, data-driven forecast. Look, every single organization out there, whether it's big or small, has to ask this question. To set budgets, to plan ahead, to grow, they have to make some kind of educated guess about what's coming around the corner. But in a world that's just full of variables, how do you get past just, guessing and start making predictions that are actually accurate? The whole secret to prediction is finding connections. It's all about spotting a cause and an effect. Like if we spend more on advertising, do our sales go up? For our example today, we're going to ask, if we make more stuff, how much will our costs go up? Finding that link, that's the key to everything. All right. First up, let's talk about the most basic method there is, the eyeball test. This is literally where you just look at the raw data and try to see if there's a pattern. It's the starting point, just a simple hunch based on what you can see. So here's some data from a company. On the left, you've got how many units they made each quarter, and on the right, the total cost. Just kind of glancing at it, the pattern seems pretty clear, right? When the activity goes up, the costs go up too. But how do we make that hunch a little more solid? To really get a feel for this hunch, the very first step is to plot all these numbers on a graph. This thing is called a scatter plot. It's just a collection of dots, where each dot is one quarter's activity and cost. Now we can actually start to see if a real pattern emerges from all that data. Okay, so with our dots on the graph, we could try to just draw a straight line right through the middle of them. A line of best fit. But here's the big problem with the eyeball test. The line that I draw might be a little bit different from the line that you draw, and that tiny little difference, it can lead to completely different forecasts. We need something way more objective. So, to get rid of all that subjectivity, we need to upgrade. We've got to move from guesswork to actual math. We need a formula that gives everybody the same, single, most reliable answer every single time. And that amazing tool is called regression analysis. It's a statistical method that takes all that old data and instead of just eyeballing it, it calculates the one single mathematically perfect line of best fit. No opinions, no hunches, just pure calculation. And believe it or not, it all comes down to a super simple formula you probably remember from school. Y equals A plus BX. This basic equation for a straight line, it's the engine that's going to power our entire forecast. And here's the really cool part, where the math starts to mean something. In business terms, Y is the total cost we're trying to predict. X is the number of units we know we're going to make. The formula then finds A for us, which is the company's fixed costs, and B, the variable cost for every single unit. All of a sudden, it's not just abstract math anymore, is it? Okay, let's get to the real payoff here and see how we can put this formula to work. This is where the magic happens, and we actually generate a specific prediction for the future. So, after running our company's data through the regression formulas, which, let's be honest, is usually done by a computer, we get this really precise equation. It's telling us the fixed cost A is about $209,000, and the variable cost B is $9.10 per unit. This is our custom-built forecasting machine. So what if the company wants to produce 80,000 units, a level they've never actually hit before? Easy. We just plug 80 right into our formula where X is. And the math spits out our answer, a total production cost of $936,900. A precise number, not just some vague guess. Having a precise forecast is awesome, but it immediately brings up the most important question of all. How good is this prediction? I mean, how much faith should we really put in this number? Is the connection between our activity and our cost actually strong, or is it just kind of a coincidence? To answer that, we need a way to actually measure the strength of the connection between our two variables. We need a confidence score for our forecast, a number that tells us just how reliable our model really is. And that measurement is called correlation. Correlation is all about putting a number on the strength and the direction of the relationship. It tells us if our two variables, like production and cost, really do move together in a way we can predict. So if the points on our graph are all marching up a hill together in a nice, tight line, we have a strong positive correlation. This just means that as one thing goes up, the other one reliably goes up too. Think production units and total cost. On the flip side, if all the points are marching down the hill in a tight line, that's a strong negative correlation. As one thing goes up, the other one predictably goes down. Maybe think something like training hours and the number of mistakes on the factory floor. And then, of course, if the data points look like someone just sneezed on the page, just a random cloud scattered all over, it means there's no correlation. The two things have nothing to do with each other, and trying to make a forecast would be totally pointless. Now, we measure this connection with a score called the correlation coefficient, or just R. It's on a scale from -1 to +1. A perfect +1 means the dots form a perfect straight line. So for our company's data, what's the score? It's 0.965. I mean, wow, that is incredibly strong. It confirms our model is super reliable. But wait, it gets even better. If you square that R value, you get a number called R squared. And honestly, this is where the real magic is. For our forecast, that number is 93.1%. Now, stop and think about what that means. Over 93% of all the changes in our costs are explained just by our production activity. All the other random factors out there combined barely even make a dent. This one number tells us our forecast isn't just a guess, it's built on an unbelievably solid foundation. But before we get too excited, even with a model this strong, we've got to take a deep breath and ground ourselves in reality. A mathematical model is a powerful guide for sure, but it is not a perfect crystal ball. You've got to keep a few things in mind. Just because two things are correlated, it doesn't mean one causes the other. That's a classic trap. And you have to remember, this entire model is built on data from the past. A major shift in the real world, like, I don't know, a new technology or a supply chain crisis, could change all the rules and make our beautiful forecast totally obsolete. So we've seen how regression and correlation let us find a clear signal inside of noisy data, turning a simple hunch into a confident forecast. It kind of makes you wonder, doesn't it? What other hidden patterns are out there all around us, just waiting to be discovered?